Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by Linode, our cloud server of choice, and we're excited to share they've recently launched dedicated CPU instances. If you have build boxes, CI/CD, video encoding, machine learning, game servers, databases, data mining, or application servers that need to be full duty, 100% CPU all day, every day, then check out Linode's dedicated CPU instances. These instances are fully dedicated and shared with no one else, so there's no CPU steal or competing for these resources with other Linodes. Pricing is very competitive and starts out at $30 a month. Learn more and get started at linode.com/changelog. Again, linode.com/changelog. All right, welcome back, everyone. This is the Changelog, a podcast featuring the hackers, the leaders, and the innovators of software development. I'm Adam Stacoviak, editor-in-chief here at Changelog. Today, Jared and I are talking to Greg Kurtzer, the founder of CentOS, Warewulf, and most recently Singularity, an open-source container platform designed to be fast, simple, and secure. It's optimized for enterprise and high-performance computing workloads. And what's interesting is how Singularity allows untrusted users to run untrusted containers in a trusted way. We cover the backstory, Singularity Pro, and how they're not holding the open source community version hostage, as well as how Singularity is being used to containerize and support workflows in artificial intelligence, machine learning, deep learning, and so much more.
So, Greg, I have to tell you that Singularity was not on my radar. It wasn't on Adam's radar. But we had two different people ping us, listeners of the show. First, Jacob Chappell, a.k.a. PHP Havoc. Thanks, Jacob. And then Andre Marcelo Tanner. I feel like I've ruined that name before. Kzap, we know well. He hangs out in our Slack. Within a few days saying, hey, you got to do a show on Singularity. And they both gave really strong pitches. So it seems like maybe you have a hidden gem here. There's lots of people using it, but there's a lot of other people who have no idea what Singularity is. So let's just start off with what it is, and then we'll figure out why it's so quiet.
That is a great question. So probably best to start off with a little bit of my background and what created it and what caused it, and why that there is this large amount of users. I mean, we've definitely hit critical mass, but nobody knows of it. So it's this kind of weird dichotomy. And so to start off with, I've spent a number of years, almost 20 years, working for Lawrence Berkeley National Laboratory as a high-performance computing architect. In that role, I had the opportunity to work with a lot of researchers, a lot of scientists, and people that had problems that they needed to solve computationally. In that role, I would develop these large HPC systems in order to solve the problems or whatever they had that we had to build up for. So about, I'd say maybe 6 years ago now at this point, time flies, scientists started asking for containers. And, my site, as well as a lot of other sites, started looking at, the various container options that exist out there. Mostly it was all Docker at that point. And when we looked through this and, we looked at the architecture of Docker, and we know the architecture of our HPC resources pretty well. We tried to superimpose one upon the other and found that, it's nothing against, Docker or the security or anything regarding Docker. Docker is a fantastic solution. It was designed for something very specific. But that architecture didn't transpose very well to high-performance computing. I mean, we have, sometimes 10, hundreds, or even thousands of unprivileged users that don't have root, users that are just regular users on the system, and they have shell access, and they're going to run their HPC and their compute-focused jobs across, lots of nodes, maybe, hundreds or thousands of compute nodes. And the Docker solution was just not really fitting that need. So I basically, I would respond to most of the users and the scientists, and I'd say, no, sorry, we can't support containers on the system. This went on for, I would say, at least half a year of basically just having to keep saying, no, I'm sorry, we can't do it, to the point where I did something kind of novel, which is I asked the scientists and the researchers and the users, I said, what problems are you trying to solve? What is the issue? And, why are you asking for containers? And we got some really interesting and fantastic responses. And a lot of it is along the lines of we needed things like reproducible software stacks. We need mobility of compute. We need absolute control of the environment that we need to run on an HPC system, and so on and so forth. There's more. And from the HPC side, from a system side, we're like, okay, well, we can't give any of these users root. We can't give them any mechanism to get root. So we have to build something that's very specific. We have to support workflows like MPI and other compute-based workflows and resource managers, which are kind of like the equivalent of orchestrators in the enterprise world. And we have to support all of this sort of stuff and support in this infrastructure. So I started looking at this and I said, well, okay, if I were to develop a solution from scratch, what would that look like? And I prototyped something. And when I prototyped it, I showed it to a few scientists who basically said, this is fantastic. When can you install it? I'm like, well, first I need to actually write it. This is a prototype, not something that I can actually install. I've created various projects in the open source realm. And the one thing that seems to be somewhat consistent is every time I start a big open source project, I know it's going to be successful when the first implementation of it, the first version, sucks and people laugh at. If I write something and it gets out there and people start saying this isn't all that good, you're kind of on some good ideas here, but the first implementation just kind of let's start over, let's wipe it and begin again.
Why do you think that is?
Oh, I don't know. I think I'm just weird. I see things a little differently. And so the first version actually ended up being extraordinarily like what Ubuntu Snaps is today. Very, very similar to that. It was basically, I was doing a p-trace of an application run as it executes. I was watching all of the system calls of everything that it's opening and building a reproducible environment based on that p-trace, that run. And then I would build what looks like a container out of that. That was version 1 of Singularity. Released it, and everyone basically said the same thing. This is great. You're on to some really great ideas here, but we need more to really make this fantastic. So when people started articulating this to me, I said, well, okay, so we have to revamp this a little bit. And, I decided early on that the first major version is going to articulate the format of the container image. One of the, I'm jumping around here a lot and I'm sorry about that. But one of the reasons why we call it Singularity is because it uses a single image format. And that is used from day one. So we basically said as soon as we hit the version, as soon as we make that change in the container image format, we have to we have to increment the major version of Singularity. So within like 2 months, we went from version 1 to version 2. And version 2 lasted for
progress.
years. And version 2 lasted for years. I mean, the uptake was just phenomenal. Within about 6 months, it was installed on most of the biggest supercomputers in the world, and just continues to grow through not just high performance computing, but through this whole new area of enterprise focused compute like AI, machine learning, compute driven analytics, data science, all of these new areas that enterprise, non-traditionally compute focused centers are now trying to do compute all of a sudden. And Singularity really being designed for that compute focus, and being really good at that and solving the problems on data mobility, containerization mobility, reproducible workflows, trusted containers, right? Being able to sign your actual container image, package that up, and then move it around, and then know that you can always validate and guarantee immutability, guarantee the fact that it's not been tampered with. Things like that. Singularity, this is basically in the direct architecture of Singularity. I mean, these are some of the primary tenets of why we created it. So it makes it a very smooth transition going from HPC and science focused compute to things like AI and machine learning and so on, and these other areas. So we've built this critical mass. We have a lot of users using Singularity at this point. I did a download and a GitHub clone count. And of course, you have to approximate this quite a bit. But we're basically looking at over 250,000 downloads at this point. And we can account for being installed on some of the biggest supercomputers in the world, and actually even being on the RFPs as line items for some of the biggest computers in the world. So we have great advances. You know, we have a huge community at this point, yet nobody outside of compute has even heard of Singularity.
So a couple of thoughts there. First of all, we did a show about high performance computing last year. It's actually, looking at the ship date, it was almost to the day, with Todd Gamblin, who's a listener and a friend of ours. He works at Lawrence Livermore National Laboratory, and he was sharing this whole world that Adam and I know very little about. And there seems to be a gap between what we call, I don't know, like industry or developers versus academia and research. And the people who are doing high performance computing, there just hasn't been much overlap in knowledge sharing and tooling and stuff like this. And so that kind of sometimes explains like why is this brand new to so many people? And yet, like you said, inside of that community, you guys have hit critical mass. You have huge computers running this. You have NVIDIA using it. You have Harvard. You have like all these very important institutions using it, but very few people have heard about it. And it seems like maybe what you point out, I just want to highlight what you pointed out there. It seems like maybe artificial intelligence needs with deep learning and other high performance computing needs are now moving over into enterprise. And that might be kind of the tie that binds these two worlds together, or at least starts to.
Yeah. There's a person that I love to quote for this line. Al Guerra, a fellow at Intel, has said that the cross-pollination of AI, traditional simulation, which is HPC and compute, machine learning, and so on and so forth, we're going to end up with systems and technology that is basically crossing those chasms. You know, we're basically able to start tying some of this together. Some of the compute side that's coming from HPC, as well as the compute side that enterprise is looking at, and leverage the technology from both. So, for example, we've been doing things like with distributed parallel jobs for a long time. We know how to do that. We know how to do things like parallel file systems. We know how to do things like very efficient batch scheduling. All right. And on the enterprise side, the HPC world is like, well, now there's this new thing called orchestration. How can we redevelop some of our scientific workflows to be service-based compute versus batch-based compute? And how can we use that to do real-time analytics, data processing, and so on and so forth, using this new technology called orchestration? And how do we cross that chasm? And so Singularity has been picked out as being, you know, from a lot of different organizations, as being this primary area for cross-pollination. And so this is where we see a huge opportunity, and we're starting to see a lot of uptake in the needs of, as I said before, enterprise-focused compute. And we're also seeing that this is a new area, right? So I spoke to one enterprise who is really leading the advancement for them at least, in AI. They're doing a phenomenal job there. But at the same token, they don't have anything to do like with batch schedulers. They don't have anything to do with distribution of jobs and actually building up an infrastructure and a resource that can actually support, you know, hundreds or thousands of these AI type jobs and the training of these AI models. So we're seeing some really interesting necessity for that cross-pollination, just because, you know, what's new in enterprise, HPC has been doing for 30 years.
Right.
But and vice versa is happening, right? Some of the new developments in enterprise and massive scale and support for this massive scale is now starting to get an interest in the HPC world, both science as well as commercially driven HPC.
That's awesome. It goes to one of the things that I talk about a lot on this show, which is the cross-pollination of ideas and techniques and even code from one industry to another, or from one language like slash ecosystem to another, and just the benefits of that across the open source world are amazing to behold. It sounds like there's a really big market opportunity here, maybe an arbitrage, where you have like, here's a bunch of stuff that HPC people are good at, and here's a bunch of enterprises who are ready to make money off of these things, and they need those things. And so maybe that's where Singularity and Scilab's trying to sit in that gap and fill that need.
Can I bring you on my pitch when I go out to VCs and whatnot? Because exactly. Yes.
We'll
huge
put into this
opportunity.
episode.
Yeah, there you go. So just listen to this and buy this license or whatever you're selling. Yes. Oh, pitch. Yes. So we're raising money for sure. Okay. So one of the things I did want to talk about, you mentioned that your version 1, it was really just a go at it, and it was like this kind of a proof of concept maybe, or like you said, if people are somewhat skeptical or they think you're crazy, maybe you're onto a good idea. Your version 2 seemed like maybe that was a semantic versioning kind of a thing, where it was just like it was going to break existing users, and so that's why you went to 2. One thing that KZAP said in his pitch, speaking of pitches, on why we should do this show with you, is that there was this big rewrite for version 3 from Python and Bash to Go and C. Just curious if you could maybe elucidate, why the rewrite, what, how'd it go, et cetera, et cetera.
Yeah, absolutely. And by the way, I love how you're reasoning through that. Yeah, it was definitely it was a proof of concept version 1, and we totally meant to do that. In reality,
that's funny. We meant to do that, but maybe not.
Everything's intentional in retrospect, right? Yeah, exactly.
Yeah, so I like how you positioned it like that.
Take me on your pitches. I'm good at this.
So, what was the question? Oh yeah. So as we've been moving forward, so version 1 was this kind of prototype, right? Proof of concept. Version 2 is, it basically solidified the idea and kind of the model of what we want to do and where we're going with it. But it was also developed in a silo. So, I mean, it's over 3 years old at this point. This is before OCI existed. This is before CNCF existed. It was Docker. Everybody talking about containers was talking about Docker. Docker, of course, wasn't the only container system at this point, but it was definitely the lion's share in terms of what brought containers, and created a household name for containers. So most everything was really focused towards Docker at this point. We did some work to enable the compatibility with Docker because there are a lot of containers that are in Docker Hub and Docker registries and whatnot. So we basically took the Singularity base, which is actually, the first version of Singularities, as well as the second version, was predominantly C. And I wrote, mostly in C. And we had some fantastic contributions and people from the community that jumped on board and basically said, well, we've got a whole bunch of containers that are out there in Docker. We need to support those containers. We need to somehow leverage those existing containers, that existing work, bring that into Singularity in a way that makes sense, and then build support for that. So that was what we've done through version 2. So the first version of Singularity version 2 didn't support Docker at all. But as we got to 2.1, 2.2, 2.3, and so on and so forth, that was brought in via Python. So we had a bunch of code that was written. Vanessa Sokat from Stanford has done a fantastic job at building all of that and bringing in that support for compatibility with Docker. But in the end, it wasn't in Go. And so it was kind of a re-implementation, looking at the public documentation, looking at the API, what can we do with it, and how do we re-implement that? So it never had perfect support for Docker. And really it was just because we were not using OCI/Docker code. So when we started evaluating, what should we be doing as we're moving forward, Singularity was really, we spent our life in a silo, of science and HPC, focusing on that side of compute. From the time that we introduced Singularity, we developed Singularity, and we're on our own pathway, which is different than what the rest of the enterprise ecosystem was going in, right? We had OCI develop, CNCF, and we had other container runtimes that are kind of coming up, and and gaining headway and gaining traction. But they're all kind of still focused on the same kind of set of original goals as what Docker was focused on. And here we are going in a completely opposite direction. And to speak honestly, we're just as much to blame for the lack of cross-pollination as anyone, because we weren't looking. We were not watching what enterprise is doing. So we came up with a solution. We're going in our way, doing our thing. And it wasn't until later when people started saying, this is we're using this for AI, or this is the perfect solution now for AI or enterprise focused compute. Here's the tools, and here's the applications, and here's the APIs that we need to support as we're going towards enterprise. And that has a lot to do with like Kubernetes. And so we're like, okay, how do we now backtrack and start supporting a lot of what the enterprise and what the industry has already standardized on? So now we had to like back up and say, what's the best way of doing this? Now, because we developed in a silo, things are really different for us than they are for what most people are used to when they think of containers. So we do have it is a very different structure. It's a very different feel for containers. So for example, a container is an actual file. It's a file that sits on your computer. If you want to move that container somewhere else, well, you can SCP it. You can FTP it. You can transfer it however you want. You can put it on an NFS server. Or in an HPC realm, you can put it on a parallel file server like Lustre or GPFS, and you can run it from there. And so it's a very different, kind of look and feel. So if you want to run a container, the command is literally Singularity shell and pointed at that file. If you want to run a Docker container, well, the command is Singularity shell Docker : / and pointed at that registry or Docker Hub or wherever it is. If you want to run from an OCI bundle or something, we support that too now. So to get back on track, my thoughts kind of bounce all over the place. I apologize for that. But we developed in a silo. We were going in our own direction. We realized later, kind of late to the party, that the rest of the ecosystem went in a different direction, and now we got to go play catch up. So we spent we spent some time. We invested in how do we properly interface with things like Kubernetes. How do we properly support new types of compute-based workflows? How do we absolutely 100% trust the containers that we run on? So, things like cryptographic validation, things like encryption, right? How do we do that? So those are the things that we've been working on, and we've solved most of them at this point. But again, it's a different solution than what most people are used to. So we're kind of a little late to the party, even though we were early to the party.
Well, it's almost like there's two parties, and then it's like, let's merge these two parties into one. Hey, everybody, did you know Singularity exists at this party over here?
Well, given your experience though in open source, I'm curious why you think you operate in a silo?
Yeah, I was going to ask the same thing. Good question.
It is a good question. We operate in a silo just because of the ecosystem of what high performance computing is typically like, right? We have these very large systems that are very different architecture than pretty much everything that's being done, at least to my knowledge, on the enterprise side. From our perspective, there's just not a lot of necessity for cross-pollination. And going back 3-4 years, AI was just really starting to get, pick up steam and whatnot. And most enterprises, it wasn't even on their roadmap yet. So there wasn't even a necessity for any cross-pollination. But that's, from my perspective, that's really the gist of why it was kind of, pigeonholed into just the HPC sec. I mean, so another open source project that I created, which is still alive and kicking and actually uses the basis of something called OpenHPC for provisioning, is a very large scale operating system provisioning and management system called Warewulf. And I founded that project in 2001, still lead it today, although honestly, I haven't been spending as much time on it for a couple of reasons. First off, Singularity has been, taking most of my time, but also it's incredibly stable, and the few amount of changes that we need has been basically driven and spearheaded by the OpenHPC community, which is a Linux Foundation and Intel project. But there's not been much cross-pollination there either. At some point, there were some fairly large web infrastructures that decided that they wanted to use Warewulf to manage their their web server load. But aside from that, I've never heard of anybody in enterprise using something like Warewulf to manage all of their servers.
What is the opposite of not working in a silo? Like, so if you're working in a silo, what does that look like? Do you just not give talks? Do you not talk to user groups locally? Are your docs not open? Are you not tweeting about, like, what does not being or being in a silo look like, or the opposite?
So the HPC industry is really big. It's a $40 billion annual, at least by 2020, it's forecasted to be about a $40 billion industry. There's a lot of conferences, there's a lot of user groups, there's a lot of meetups and all this, but it's all really, that whole thing is kind of like siloed. It's the example you guys gave about, there's two parties going on is, I think, a really good one, because the people that are at that party almost never go to the other side, and right. Vice versa. I mean, there's just not a lot of cross-pollination. They've been two completely separate worlds for so long. At one of these conferences, at a supercomputing event, which last year we brought in about 13,000 people, just to kind of give you an idea of scope. Usually wherever supercomputing goes, we sell out the whole city. I mean, hotels, usually going for like 3 to 5 times their normal price because there's just no room anywhere. There were some people from the more traditional enterprise side that are like looking at some of the primary tools and resources that we rely on in high performance computing, confused on why they even exist, because Kubernetes can do that or something else can do that. And it's, there's just such a misalignment between the two communities, and that cross-pollination, especially now as we're seeing the advent of things like artificial intelligence and machine learning focused on the enterprise side. I think this cross-pollination is really fortunate. And it has to happen. I mean, it's going to happen. So that's, and to go back to the earlier point, that's really why we've created Scilabs, why that there's such an interest to commercialize this as an open source project. How do we better support both sides of this? And how do we sit in between and offer services to both sides, and offer the benefit that both sides have been able to glean, and then help to bring these two communities together?
This episode is brought to you by Clubhouse. One of the biggest problems software teams face is having clear expectations set in an environment where everyone can come together to focus on what matters most, and that's creating software and products their customers love. The problem is that software out there trying to solve this problem is either too simple and doesn't provide enough structure, or it's too complex and becomes very overwhelming. Clubhouse solves all these problems. It's the first project management platform for software teams that brings everyone together. It's designed from the ground up to be a developer-first product in its DNA, but also simple and intuitive enough that all teams can enjoy using it. With a fast, intuitive interface, a simple API, and a robust set of integrations, Clubhouse seamlessly integrates with the tools you use every day and gets out of your way. Learn more and get started at clubhouse.io/changelog. Our listeners get a bonus 2 free months after your trial ends. Once again, clubhouse.io/changelog.
So, Greg, we both mentioned Scilabs offhanded. We've obviously been talking about Singularity. You said that the reason for Scilabs at the end of the last segment. Let's talk about that relationship, the dichotomy between the open source project. Maybe you can tell us about Singularity licensing and all that, what Scilabs brings to the table, and your thoughts on commercializing open source in general.
So, with my prior hat on, working for U.S. government, Department of Energy, building open source projects was always, it's kind of an incidental thing. It's like, we need something, let's build that. Let's hopefully the community will get involved and it'll help and whatnot. There was never a necessity to build a business model. Now, as I've now moved away from Department of Energy, created a company, and this company is built around the idea of an open source project that has gained a lot of momentum, gained a lot of steam, and how do you take the open source users, the open source community, and monetize it in a way that allows us to be not only sustainable, but hopefully a little bit profitable, and not alienate the open source community, not do anything that creates a resentment or creates any sort of a misalignment, right? And that's a challenge. You know, there's been a lot of companies out here that have really tried to monetize on open source projects, and you know, it's a very difficult tightrope to walk. Red Hat has been incredibly successful at this, and there's been others as well, but there's also been ones that have not been successful. And there's ones in our own ecosystem in the container world that right now is trying to figure out still, even though they've done incredibly well for themselves from a business perspective, they're still trying to figure out what that business model looks like. So I have the luxury of coming at it from an open source side where I understand, you know, I've built communities, I've built projects, and I've watched how companies have not done this right, and I've seen only a couple that actually have done this right. And so I'm taking my own stab at it. And basically the main part of what we need to be doing is we need to be making every piece of software, every line that we write for Singularity has to be open source. The first thing we do, we don't have a private repository for Singularity within Scilabs. We basically push everything live. Every bit of development, everything we're testing, everything we're playing with goes directly into the open source community. In a matter of speaking, metaphorically, you can almost think of that as Fedora. Then what we do is we'll take snapshots of that. As we've done releases, open source releases, we will take snapshots and we will basically say, okay, we're going to build this in a supportable way where we know exactly what it is. We know how we built it. We know how it's supposed to work. It's curated. We know exactly what this is. And this is now a supported version. We call this Singularity Pro. And we license that and we offer support on that. But it is a feature equivalent to what's out there in the community. And we're doing that on purpose because if we were to add any additional features to that or make any additional spins on that that are not also available in the open source version, then what we're doing is we're holding that open source community hostage, in a matter of speaking, or that project. We're holding that hostage. And we're holding that hostage to our business model. That model inherently is broken because as soon as you limit or you stunt the uptake of one, you're going to adversely affect the other. So it is a mutualistic synergy between the open source version and the commercial version. If the open source version does fantastic, we're hoping that we get some small percentage of that will basically move over and become, you know, commercially supported. And we will then be able to, you know, build a revenue line, build a business line. Now, that's one business offering.
I got a question for you there on that note before we move.
Yeah.
Does that mean that others can support Singularity as well, like you are? So I'm thinking like the tide lift models, for example.
Yeah, absolutely.
So you're not saying that you're the only supporter of it. It just means that you're taking those snapshots so that you can put them to the side, call it Singularity Pro, and provide support and licensing.
Yeah, and it's a risk, right?
Yeah.
But that's the risk with open source. I mean, anybody can always fork an open source project and then spin it their own way.
I like how you're not holding it hostage. You said that's the point I wanted to get at, was that you're not even holding the business model hostage.
We believe 100% that if you build a company and you build, and this is one of the reasons why I think my open source projects have always done very well. It's because I build these based on integrity. I build it based on stated values, stated ethics, and I maintain that. I believe that the best project, the best product, and the best supplier is going to win. And what makes someone the best is, well, you're not only doing a fantastic job of what it is that you're set out to do, but you're also, you have a high level of integrity. You have a high level of respect, and you want to work with people. So if somebody else were to come along and try to fork Singularity, well, they're going to not only have to beat me on being better at support, but they're also going to have to beat us at being, higher levels of integrity and everything else. And if that's the case, then they deserve to win. So that's the game that we're playing is we want to be the best. And we have an advantage because the primary developers of Singularity, you can believe I have lured and hired because it's not just me anymore. And as a matter of fact, I've hired and recruited people into the open source community and into the company who are much better people at developing software, much smarter than I am. Because believe me, many people can do this better than I can. I told you about my version 1 already. So,
I changed your direction. Though. Go back to where you were going. I don't want to derail you completely.
Where was I going?
I don't know.
Completely derailed. Good job, Adam.
Sorry about that.
So I'm trying to remember what the question was. Can
you were
remind me of the
moving on
question?
from the fact that you're not holding the open source hostage by describing, you supporting it.
Oh, yeah. Thank you. So our first, the first product that we have is basically just a respun version of the open source code that's out there. And we professionally support it. We offer professional services. We offer, support for it, education, everything you can imagine. It's somewhat obligatory, right? We have a open source project. We have this piece of software that we're supporting and we're maintaining out there. We have to be able to support it. We have to be able to help people with it. So those are the obligatory kind of offerings. Then we have some uniqueness that this particular container system offers. So for example, one of these is we support cryptographic signatures. I've alluded to this already previously. So if you were to sign a container, and remember our containers are a different format from OCI, right? This is a new format. The format is capable of supporting OCI and encapsulating OCI and Docker containers and whatnot. So we can take all of that and we can properly encapsulate it into a single file. We no longer require any registries or anything to run that. But because it's now in a single file, a single binary file that has an open standard behind it, we can do things like cryptographically sign it. And in this file, which was originally modeled after the ELF binary, we can add an object block for a cryptographic signature. So now this cryptographic signature block can basically do things like guarantee immutability and whatnot of the file and accountability, right? This is really interesting because when you validate, when you build a container, when you sign a container, it uses a very traditional PGP type public and private keys to do this. So you're going to sign with a private key. Nobody else has that private key. And when you distribute it, you want to share your public key out. So when people validate, they're going to be validating against your public key, and they can guarantee, again, immutability. And because they have your public key, I can't say that right now, because they have your public key, they can guarantee accountability. They know who signed it, right? So one opportunity that we have is to add value to this open source project. So whether somebody's using this as an open source project or whether somebody's using our commercial project, if we were to, let's say, host a key store for public keys, so it's very easy to cryptographically sign your containers, push those keys into our key management service, and then however you distribute your container, wherever you bring it, you can do a Singularity verify pointed at that file, and it knows how to contact our key store, or you can run your own key store on-prem and validate that container and see who signed it. So you can say, for example, now you can say definitively, well, if I trust Greg, I will trust any containers that he creates. If I trust Ubuntu, or if I trust NVIDIA or Red Hat or SUSE, right? As long as they have their key, they've signed it with their key, you can now absolutely guarantee that level of trust. This is really important when you start thinking about some of the recent CVEs that just happened within the container ecosystem, right? There was a malicious container could actually do damage to the container runtime on the host, such that, let's say, for example, you're using runc or using, Docker or something, right? If you were to spin up a malicious container, it can actually create a Trojan inside that that program that basically spun it out. So runc was, had a CVE just recently against it because of this.
That's not supposed to be possible.
Oh, it's not supposed to be, but it's.
I don't think you understand how these things work. You can't do that.
That's why the signature is so important.
Yeah. So you can do, from our perspective, you can do one of two things, or you should do one of two things. You should absolutely never run a container as root. That's first off. Second off, if you have to run a container as root, you should never, under any circumstance, run an untrusted container as root. All right. So here's a really simple example. As a system administrator, I imagine that there's a lot of system administrators that are going to be listening to this show. So as a system administrator who has root on a very high visibility production system, it's probably discouraged. It's probably looked down upon to go to the internet, download a whole bunch of random code, and start executing it as root on your production system. Right? You don't want to run untrusted code as root. Now, the container ecosystems do what they can to isolate, but, there's always going to be this, at least from my perspective, and this is now I'm getting into religion, so I'm sorry if I'm going up against somebody's religion here, but if you're, POSIX was kind of defined around the idea of users and privilege and whatnot, and we have a very strong standard for, well, the super user is the super user, right? You have, when you're root. The whole system is yours. Now, what we're doing with the container ecosystem is we're saying, yeah, but root over here is not the same as root over here, is not the same as root over here. Everything's seeing kind of this different thing, but at the same token, POSIX has defined, and our traditional Unix standards have defined that, well, root is root, right? So we're trying to limit what root can do. And I know I'm going off on another tangent here again, but that's kind of the premise of this, the security issue from our perspective, right? If you want to limit the exposure, well, don't run it as root. But if you have to run it as root, make sure it's trusted. We offer a trusted solution here. So going back now to the business model, and I'm sorry again for the tangent. In terms of the business model, we have a key store. And this key store plus Singularity plus the design of the Singularity image format gives us the ability to absolutely trust these container environments. So if you're going to run it as root, you should run something you trust. And we offer that as a service now. So it is a free service that we're offering, and we're going to be figuring out some way of monetizing something at some point. The business people keep telling me that that's important. So working through that. But this is ways that you can
service.
Say that again?
Is it a popular service at this point, or is it still new?
We haven't even released it GA yet.
Okay.
As a matter of fact, we're going to be releasing it GA. Yeah, in about a month. So we're expecting to see some increase and uptake. But at the same token, this is still brand new for people, right? I mean, most people think of containers and OCI has a portion of their spec talking about how to sign containers and whatnot. But it's signing the metadata for those containers. It's not actually signing the runtime format, right? Those containers are actually tarballs, and those tarballs get splat out to the disk, and that creates new data. The signed tarball, well, that relates to the tarball, not the new data. And then that new data could honestly take a life of its own, and nobody would ever know. So there's our format is the actual runtime format. So I mean, there's no metadata. There's no tarballs. You download like a 10 or 100 gigabyte container. You type in Singularity shell and you're instantly inside that container because it doesn't have to splat anything out the disk.
And what you get is what's been signed.
Yes, exactly. So that's one of our business models, which is to add value. Don't hold it hostage, but somehow add value to that open source piece of software. And we can do that commercially, right? That's a cloud service, right? That's not something that we're planning on open sourcing. That's a cloud service.
But you're making it free.
For now.
We'll
probably so we've talked about the freemium thing too. And I have mixed emotions about it, but at this point, what we know for sure is we need to drive adoption. We want people to use this. We want people to be able to run trusted containers. We want people to be able to leverage Singularity in our format and make good use of it within their environments, their ecosystems. And we have to hit critical mass, right? Or at least we're trying to. Right? We've hit it in HPC.
You mentioned pitch deck, so you're raising money, right?
Yes.
So you're going to have to hit critical mass. Like that's the trade-off, right? I mean, if it was all bootstrapped, you could open up, is it called Scilab's Cloud? I'm reading about that. Is that what you're referring to, the service?
Yep.
You could open that up, just charge some money from day one. And if it's, if the gross revenues, cover your expenses and there's some left over at the end of the day, you got your profit. But you're not going that route.
101, y'all. Thanks, Jared.
You're welcome. But I was saying, you're not going that route.
I'm taking notes.
You're going for the home run.
So we're going to drive. We're trying to drive adoption and usage. Not just get just enough to pay the bills. We want to actually encourage people to utilize this. We want to help support the ecosystem and change how people think of trusted environments. We want people to feel like they can absolutely trust whatever environment that they're in and manage that environment like any other data that they have to manage.
Did you consider closed source? Was it even a thought? Just because that simplifies business cases a lot, but it complicates other things.
So for Singularity, never considered it. For our cloud development, it's a cloud service. So that's not something that we're open sourcing. So that is definitely a closed source. But we've gotten some really interesting information, which is everybody's talking about cloud. Everybody's talking about getting all their apps and everything up to the cloud. And so, we developed this cloud service thinking everybody wants to go up to the cloud. A really interesting spin on this is that, and it's something I totally didn't expect, is that almost everybody, well, maybe not everybody, I'm exaggerating, maybe about half of the people that we talk to wants to run that on-prem. And I wasn't expecting that. So we are figuring out how to relicense and rebrand our cloud services and allow people to run those on-prem. And we have several different cloud services at this point. The key store that I was mentioning before is just one of them. Another one is a build service. So you can actually build containers without requiring root or without requiring any sort of privilege escalation, because we have a service that does that in a controlled way. We also have something called the container library. Now, in compute, and I'll give a little bit of background on this. In compute, there is various regulations. In pharma, for example, and in on the science side and the bio side, they have various FDA regulations even that they actually have to manage the environments for any software that contributes to diagnosis of a medical issue. Anytime software is involved in that entire stack has to be treated as a medical device. And a medical device has to be archival for 5 to 10 years, meaning we have to be able to reproduce those results and reproduce that environment for 5 to 10 years. Well, Singularity provides a perfect solution for that. So our container library, one of our services, is kind of built around the idea of what are the specific benefits of this binary image format that we have, and how do we archive and always allow people to go back to previous workflows and so on and so forth. So that's a feature that we have in this container library. And the other one is, a lot of people talk about DevOps and they pass recipes around. They pass the source code, in a matter of speaking, around for their environment. Well, again, because our containers are 100% immutable and cryptographically verifiable, why don't we just pass the container around? And then that way you never have to rebuild it. So it goes from the developer, you build that binary container, and then it can run through a DevOps pipeline that can be completely, built up for whatever the pipeline is and customized via CI/CD, integrations and whatnot, and then come out the other side as this binary immutable image has passed all of this. This gives us the ability now to inject things like the security teams into the DevOps workflow, right? Because once this pipeline, once this container image is going through this pipeline and it gets to security, and security is like, okay, I've audited this, I feel good about it, I'm going to now sign it and then continue it on its way. Well, we just added a cryptographic signature on it that wherever you run in production, you can say, I'm never going to trust this container unless it has this key, fingerprint. And if it has this fingerprint that your security team owns, then I will allow it to run in production. So it gives us the ability to do things like inject security back into the DevOps workflow. And it changes things. It changes how we're doing this. So all of this is in our cloud services that we're building right now. And people are asking for it for not only cloud access, but also on-prem. So in terms of, again, kind of building our model, the idea is if we're going to build anything that's non-open source, it has to 100% add value, not hold hostage, but add value to that open source code base.
This reminds me of Isaac Schluter. So we have another show. I was
right there with you.
Were you right there with me?
Yes.
So we have a show. I'll pitch Adam's show here. Adam has a show called Founders Talk, and his most recent episode of Founders Talk, we'll link it up in the show notes for listeners. It's fascinating. He spoke with Isaac Schluter, who's the co-founder and what's he now, former CEO, chief product at NPM, which is a hockey stick style container package registry, which is a similar business to a container registry. And he had very interesting insights, which I won't share here. You can listen to all of what he says about going a service-based and on-prem at the same time. And some of the things they've learned. So I would just submit that to you, Greg, as something that you might want to listen to and learn from his experience. Not that it's going to one-to-one match what y'all are up to, but anytime you can learn from somebody else's experience, you can save yourself bad experiences as well.
That just leans into the whole idea of cross-pollination.
Yeah.
Right? Like this is the JavaScript, package management world, potentially influencing Greg and future stuff around this cloud.
Yeah.
Exactly. Thank you for that pointer, by the way.
Go check that out.
This episode is brought to you by Raygun. Raygun recently launched their application performance monitoring service, APM as it's called. It was built with the developer and DevOps in mind, and they are leading with first-class support for .NET apps and also available as an Azure App Service. They have plans to support .NET Core, followed by Java and Ruby in the very near future. And they've done a ton of competitive research between the current APM providers out there, and where they excel is the level of detail they're surfacing. New Relic and App Dynamics, for example, are more business-oriented, where Raygun has been built with developers and DevOps in mind. The level of detail they're providing in traces allows you to actively solve problems and dramatically boost your team's efficiency when diagnosing problems. Deep dive into root cause with automatic linkbacks to source for an unbeatable issue resolution workflow. This is awesome. Check it out. Learn more and get started at raygun.com/APM. Kubernetes is well known for its community. Like if you have a conversation around Kubernetes, like even the founder of it will say it's about community, right? And then they've had that lens since the beginning. What is your perspective on community and how are you using that to grow?
Okay, so the community, the open source community, and the idea of what it was to be, an open source community and how to maintain an open source community has changed, right? I mean, back when I first started doing it, the open source community was brutal. People were mean. People, were obnoxious, and they liked to prove everybody else wrong and prove themselves being better. And it was competitive and whatnot. It took a very hard and calloused personality to be able to excel in it. And I'm not that kind of a personality. I've tried working with various other open source projects because I love the idea of open source. I'm a biochemist by degree, turned into a computer geek because I thought it was totally cool how we were able to create bioinformatics tools based on Linux in the mid 90s. And I thought that was fantastic. So I just immediately became enamored with the idea of open source, but I didn't have the personality. honestly, to really be part and be so callous to be able to handle this sort of things and whatnot. So I actually found it easier to start communities and start them with a different tone, start them with a much more friendly tone, a much more considerate tone. And, people always felt comfortable. So, I mean, as an example of this, I would, start up a mailing list, start up an IRC server or join Freenode or something and start building up the community, start chatting with other people. Back in the day, we had Fresh Meat. I don't know if you guys remember Fresh Meat, where you post your open source. Just a
I haven't
quick
heard that
funny
name in a long time.
Just a quick funny story. My mother at some point decided to do a search for me, and Fresh Meat came up, and she was like, "I don't know what Fresh Meat was. I was scared to click on the link. Why are you on Fresh Meat?" But I mean, Fresh Meat was really the big, way that you kind of get your new open source stuff out there. And so I post to Fresh Meat and build this community. But it was about just, super friendly, wanting to just chat with people, be real with people, be open to new ideas, teach people, bring them up to speed and whatnot. I mean, even, early Warewulf days, early CentOS days, people would ask questions. I mean, on the CentOS mailing list, people would say, "Oh my God, I'm stuck in Vim and I can't get out." And they post questions, really simple, basic questions. And I'm always
for many people.
And I'm always so happy, to
thousands of developers
help out.
are fighting that fight on a daily basis.
Sorry. And
continue.
No problem at all. I'm just thinking of
we
all
have
of
the tweets to prove it.
There's literally hundreds of developers currently stuck in Vim as we speak, just trying to get out.
Listening to the show.
That's
and
right.
Being a Vim, I always ended up landing in Vim and did most of my development in Vim. So I feel the pain, and at the same token, I was always really happy to help people get out of it. And so here, from the perspective of an outsider, here's the lead developer, the project lead, helping somebody with these extraordinarily basic questions, and I think that is absolutely necessary. And if it's the 5th time or the 10th time or the 100th time that question gets asked, it's obviously still an issue. You should still answer it. And referencing, if you just did a Google search and just looked through their logs and the archives, you'd be able to find that, I'm sorry, it's a pompous response. And it's not very welcoming. So I would always, be very supportive, very appreciative of everybody that came into the group, whether they're developers, whether they're users, and set the tone right away as that, and set it from the top down. I didn't tolerate people that became, the jerk mentality. And it's nice to see that many more open source projects are adopting this behavior, but I feel as though it was a critical facet for what makes a good, strong community. And how do you develop that strong community and keep it on track? Not sure if that completely answered the question, but that's been my experience with open source communities and leading them and running them.
Well, I'd definitely say that your success, especially with CentOS and building that into what it still is today. I'm not sure. I wasn't familiar with Warewulf. Didn't hit my radar previously, but I think it's safe to say that what used to be a if you're looking at open source competitively, which some people do, some people don't. I think friendliness and setting expectations and all the things that you were doing back then was a competitive advantage back then. Like, it set you apart. It's like, wow, this is actually a nice group of people to be around. I would agree with you that more and more it's becoming, kind of table stakes to a certain degree for successful communities in open source, is to that be the baseline of what they do. I'm curious with regards to specifically with Singularity and the dichotomy that we've been discussing about between, the commercial enterprise and the open source project, and then also this siloed HPC world, bringing that into the enterprise world. How do you build out other companies, other individuals who are willing to, contribute back to Singularity or to really buy into the project at a contributor level with the enterprise attached, with the commercial side attached? And then also even do you want those kind of there's open source projects where it's like somebody had a good term for it. It's like where you can look at the code, like it's open code or it's viewable code, but it's not as if the company actually wants you helping unless you're like doing a trivial bug fix or something. In terms of like features and direction, how do you manage the community side of those things when you're trying to build a business around an open source project where maybe the community's contributions may actually go against the business's interests?
So you brought up a couple of really just amazing points.
Thank you. Tell me more. No, just kidding.
So, for example, when you have a company that releases some software and they release it to the open source community, it's almost becoming a marketing initiative. Right? They're not interested in the collaborativeness and the openness and the community side of releasing software into the open source community. What they're really interested in is getting that stamp. We are open source, and they will just release it. They don't take contributions. They don't or they don't look favorably upon them. Or when they do get them, due to wanting to run and manage and host all of their own copyrights, I've seen organizations that will actually rewrite PRs, rewrite patches using all of their own resources because they don't want any contamination of copyright. And so the fact that it is open source it's a marketing vehicle, right? That's one side. There are companies out there doing it. That is not our side at all. We are first and foremost, we started off as an open source community. I developed a company. I have a lot of experience with open source. I'm a huge open source advocate. And when I say open source, again, not from the marketing perspective, I'm an open source advocate because there are very important advantages that the open source community and the development model brings to bear. So we absolutely support collaboration. We want other companies, other organizations adding code, being part of Singularity, joining our Slack, joining our Google group, and contributing. Whether it's just simple, here's my experiences using it. Whether it's documentation, whether it is working on the core code, or whether it's even going out there and just, speaking at events and user groups and whatnot. We absolutely want it. We've had contributions from companies, from individuals, obviously from companies. We've had a lot of academic and other government involvement. So all of this is incredibly important to us, and it is extraordinarily appreciative. And this is why we put every bit of our code, first and foremost, into the master branch, because we want to engage in that collaboration. We want to foster that communication and build a product that is, or both a project as well as a product that is really meeting the needs of the users, right? We're not out here trying to push something that doesn't exist. I mean, everything that we've done is because we're solving a problem that our users are having, that people are complaining about, and we're solving pain points. So that's kind of our model. And if we're not engaging with that community of users, we have no idea if we're even solving the right points. And honestly, I want people solving those points with us.
A question on the pro versus open source, though. I'm curious, just because I'm not involved in the details of this, how usable is Singularity on its own as just open source and not via the stamped version? Like, is there any incentive to use the straight up open source version versus Singularity Pro?
If you don't need commercial support, there is no advantage at all. Go use the open source stuff. Okay. If you represent a company, if you represent an organization that doesn't want to rely on best effort support from a group of people sitting in a Slack channel, then that's when you want to contact us. Right? But in terms of individuals, in terms of developers, in terms of contributors, and many organizations that honestly just want to work with open source software. Go use it. There's no limitations. We are not holding it hostage, and we encourage it. We would love people to be using our open source software.
Well, I don't think anybody will second guess your bona fides, or however you say that, considering just your long history of building open source communities and projects. So that's awesome. How has it grown so far? I mean, you have people out there who are championing this. You have, like you said, we've named off a few of the organizations who are using Singularity. How has the contributor base grown beyond, Scilab's quote unquote walls? And I know you're all remote and around the world, so there aren't any walls, but you're, beyond your payroll. Have you had an uptick in not just users, but is NVIDIA, SUSE, these other organizations, are they getting involved in really making this feel like a community-driven project, or are you still trying to get that ball rolling outside of Scilabs?
It's kind of funny because every time, and not every time, mostly when we have people join our community, and they start, being really productive, and they're adding features, they're adding code, and they start to really kind of, get used to us, and everybody starts to, we all like each other, we're all friends, and we joke around a lot. I typically, and maybe this is good, maybe this is bad, I don't know, but I usually recruit them. And I try to get them to work for Scilabs. And in doing so, a lot of times what we're seeing is, well, a lot of times
you're gobbling up the community.
Yeah. And I don't know if that's good or bad, but the fact is, it's actually, it's hard to find, it's hard to find the development and the developer skills that we need to basically run and create a whole container platform.
Yeah.
It requires not only a lot of knowledge, in the upper end of application design, but also going all the way down to kernel. And there's not many people that are really anxious and eager and love to do operating system coding anymore. To kind of poke fun at this a little bit, we see, and we saw this as well when I was working for Department of Energy, as we're trying to recruit scientists. It was really hard because, coming out of, the universities and the PhDs and whatnot, instead of doing research in science, they wanted to develop games for the iPhone. They're developing a dog walking app or something instead of, something, solve, instead of wanting to cure cancer, or something along those lines. So we've seen it as well, again, with my other hat on, my previous hat, as well as, from Scilabs. It's hard to find the right people. And it's really nice when we do have an open source community, because we are attracting individuals, not just corporations, but individuals at those corporations. But I mean, there's the personal side of it, and you get to meet these individuals and develop relationships with them. And as you do it, it's really easy to offer them jobs.
So the takeaway here, developers out there in developer land, is hop on the Singularity repo, start contributing back significant things, and you're going to end up on a job at Scilabs here pretty soon.
Expect an email. Make sure you have your email in your GitHub profile, so it makes it a little easier.
Yeah, exactly.
So to get back to the question on a more serious note is, we've had a lot of people join our Slack, both, in contributing to GitHub, as well as joining our Slack, being part of our mailing list. We have an extremely active and friendly email list. The same thing on the Slack side. It's a lot of, very friendly people. Just all, honestly, it's as much just, idle chat and, getting to know each other and having fun, as well as, developing code and kind of coming up with new and innovative ideas for doing kind of really amazing things. We have a lot of people that are involved with the process. In terms of GitHub, actually, I don't even want to quote a number because I don't remember, but I think it was, it's not a huge project when you compare it to something like Kubernetes and whatnot. But we have, I think it's about 1,000 stars, and now it's making me want to look. I think it's like 1,000 stars, and I think it's under 100 contributors. But I mean, it's a good amount. And we're all very appreciative of everybody who wants to join the community. And again, someone doesn't have to be a developer to join. As a matter of fact, we encourage non-developers as well, because the amount of benefit in terms of feedback, in terms of just looking at things, being part of this, helping potentially with documentation, even just pointing out bugs, pointing out issues that they're finding, or or being a conduit for reaching other people is so valuable. It's so helpful. And so we are very receptive of that.
On the repo now, you got 98 watchers, 998 stars, and 252 forks on Singularity.
So, it would be fun. Let's after this podcast is it gets out there, it'd be fun to see how much this increases.
Change
All right.
effect.
Okay, listeners, get out there, Singularity, star that repo. Make us proud.
That's right.
Because we know that all value in open source can be derived by star count. That's like the ultimate goal, right?
That's
Just
true.
Stars.
That's the only metric that matters.
That's the only metric that matters in life.
Mm-hmm. I'm curious your focus, though, when it comes to the future. Where you'd mentioned community, you'd mentioned business, you'd mentioned your principles around open source. Where are you personally placing your focus around Singularity and Scilabs? What are the biggest challenges you're facing today to move forward?
We are placing a lot of emphasis and investment in everything computational. So somebody asked me recently, are we an HPC company? No, we're not. We are a compute company. We are focusing on all of the different types of compute-based workloads that are out there. And we want to use all of the cool tools to do that. Everything from Kubernetes to HPC resources, InfiniBand, parallel file systems, batch scheduling systems, and go all the way out to edge and cloud and IoT. And this is where we're spending a very reasonable investment in terms of moving forward. We want to facilitate the movement of AI workflows. So for example, as opposed to more traditional compute, where basically you have a big HPC cluster and you run everything on that big HPC cluster, there's a lot of AI and ML workloads that are distributed. You may need a big HPC type system to train that model. But once it's trained, you now have to distribute that model wherever you're running your inferencing. And in some cases, the inferencing and where you're executing these models is not extraordinarily, it doesn't need a huge amount of resources in terms of compute in many cases. Some cases, of course, it does, but we're seeing really different types of workflows. And these workflows, in a lot of cases, it's, we're still doing science trying to figure out how best to support and optimize these workflows. But these workflows are really interesting to us because Singularity offers a really interesting and an elegant solve for how do you take these workflows? How do you, for example, how do you build and train your model? And then how do you distribute that model to where you're doing the inferencing? And where you're doing that, it could be any sort of workload, right? You could be doing streamed AI. You could be looking at data analytics. You could be doing all sorts of different types of things. But the workflow as a whole, and how do we support that? How do we create an architecture to build a pattern that we can replicate easily and better enable easy wins where everybody's looking at AI? That's one of the big, the big areas that, big organizations are like, AI is on our roadmap. We want to get there. We want to do it. But we don't know how to enable any quick wins. And it's really complicated and it's a really high lift. And we're just going to keep watching it for now. We have this really cool technology that enables those quick wins, that enables the distribution of those workloads, that enables mobility of models. And that's something that we find really interesting as we're moving forward.
You mentioned somewhat in the show, I can't remember if it was just in a breaks only or if it was in the show, jokes around slides and Jared helping you with the next VC pitch. So you'd mentioned that you're raising funds. If there's any venture capitalists listening, are you seriously raising funds? Should they reach out to you? What's your state of, fundraising? And how does that play into the sustainability of the project?
Great questions. We are seed funded at the moment. And right now we're burning on the seed as well as living off our revenue. So we are going to be doing a Series A pitch. Kind of interesting is that as we are evaluating our Series A pitch, and doing comparables, it seems like all of our comparables are more like Series B and greater, just because we've de-risked the company at this point so greatly. So, but yeah, there is a raise going to be coming up here pretty soon. And happy to have any introductions if anybody listening is is interested.
I say that because just a few shows ago we did an entire show with Joseph Jacks around OSS and commercially backed or venture backed commercial open source. So I'm sure we're picking up more interests around there, and I'm sure that any new audience from that kind of show too just is listening. Plus, I'm sure there's a lot of VCs out there in that venture capital world paying closer attention, and they're listening to shows like this to get insights.
We should have a changelog discount. If anybody comes and they reference changelog, we can have a discount code.
Right.
There you go.
Give me $1 million, and it'll actually be will act as if it's 1.2.
Right. Yeah. You get an extra 5% ownership.
Right.
That's no big
like
deal,
that.
right? 5% isn't that much, right? Not amongst friends.
We didn't really mention the Mac app either. I don't know how much that plays into it, but maybe paint the picture of the future of getting involved. The people who want to play with this. There's a Mac app. There's some user groups coming up. Help people that are looking to get plugged in.
Fantastic point. As part of our, you mentioned the Mac support. Something that we are working on right now and should have something released by next month is something called Singularity Desktop, which is basically just being able to run Singularity and all your containers on your Mac. And again, the command line interface for Singularity is incredibly simple. So it's like Singularity shell pointed at your Ubuntu container or your CentOS container or SUSE or TensorFlow even. And you hit enter and you're now sitting on your Mac. You're now sitting in that same terminal. We're now running Linux, running inside that container. No dependencies or anything. You just install Singularity. It manages all of that operating system support and whatnot. Also going to be doing the same thing for Windows here in a little bit, but of course we're first hitting with Mac just because it's a little bit closer to home in terms of how to enable that on the Mac. So that's something we're working on. So imagine you don't need a VM anymore, or install VMware or anything to run Linux on your Mac. So that's something that we're working on. The other thing as well, again, this is kind of on the community side, is we've had a lot of people really interested in a user group. So we reached out to some people and we said, hey, is anybody interested in this? San Diego Supercomputing Center basically raised their hand and said, yes, we're really interested in this and we'd love to help support this. So SDSC, the Supercomputing Center in San Diego, is going to be hosting our user group. It is next month. We just closed our CFP. So we're now just basically building up the agenda. But if people are interested, maybe that's something that, I don't know. Guys, can we post a link for that?
Link in the show notes for sure. We'll make sure we get that from you and put that in the show notes. So listeners, that when you go and you listen to a show like this, you know what to expect. Great links in the show notes. So hit that up. Links there.
Very cool. I didn't want to presume that I could plug and whatnot.
No, please do.
Too much. Okay.
No, absolutely.
So, but yeah, so that's happening next month. We have some great talks aligned. It's going to be mostly focused on the containerization side of compute. So if people are interested in compute and whatnot, and how to containerize those workflows, both HPC, science, as well as AI and enterprise-focused workflows, I encourage you to check out that user group.
Good deal. Thank you so much, Greg, for coming on the show, man. It's been awesome to hear from you and just Jared, I'm so glad we're in the know now. I feel better about my life because now we know about Singularity. And
that's right.
Maybe that's what the audience feels like too. So audience, if you do, we have discussions on our show.
That's right.
So go back to changelog.com, look up the podcast. Every single podcast has discussions now. So Greg, I'm sure you're going to be tuning in and listening to our community coming there and sharing more stories with you or questions or whatnot. So if you've got those questions, head to changelog.com and jump in the discussions and have a chat with Greg and the rest of us about Singularity in the future, where this is going. But Greg, thank you so much for your time. It's
been a pleasure. I love chatting with you guys, and both the on-show as well as the off-show discussions have been fantastic. A lot of fun. Enjoyed it thoroughly. And if you guys ever want to chat with me again, open welcome.
All right, thank you for tuning into this episode of the Changelog. Hey, guess what? We have discussions on every single episode now, so head to changelog.com to discuss this episode. And if you want to help us grow this show, reach more listeners, and influence more developers, do us a favor and give us a rating or review in iTunes or Apple Podcasts. If you use Overcast, give us a star. If you tweet a link. If you make lists of your favorite podcasts, include us in it. And of course, thank you to our sponsors, Linode, Clubhouse, and Raygun. Also, thanks to Fastly, our bandwidth partner, Rollbar, our monitoring service, and Linode, our cloud server of choice. This episode is hosted by myself, Adam Stukowiak, and Jared Santo, and our music is done by Breakmaster Cylinder. If you want to hear more episodes like this, subscribe to our master feed at changelog.com/master, or go into your podcast app and search for Changelog Master. You'll find it. Thank you for tuning in this week. We'll see you again soon.
I'm Nick Nisi.
This is K-Ball.
And I'm Rachel White.
We're panelists on JS Party, a community celebration of JavaScript and the web.
Every Thursday at noon Central, a few of us get together and chat about JavaScript, Node, and topics ranging from practical accessibility to weird web APIs. Jared, I just have to ask a very serious question. When you're using that operator, do you actually blurt out bang, bang? If you were working in an office, would everybody just look at you?
I don't blurt it out, but I definitely say it in my head every single time.
Join us live on Thursdays at noon Central. Listen and Slack with us in real time, or wait for the recording to hit. New episodes come out each Friday.
Find the show at changelog.com/JSParty or wherever you listen to podcasts.
I'm Daniel Whitenack.
And I'm Chris Benson. We host Practical AI, a show making artificial intelligence practical, productive, and accessible to everyone.
You'll hear interviews with AI influencers and practitioners, and we'll keep you up to date with the latest news and learning resources so that you can cut through all of the hype.
In terms of environmental sustainability, like Microsoft has won numerous awards for that. We've been carbon neutral since 2012. But the way we look at it is, even if Microsoft was absolutely perfect, there's only so much impact Microsoft as a company is having just in our own operations. So how could we scale out even more? AI for Earth was really our answer to that question. By dedicating this $50 million over 5 years, that enables everyone to be able to partake.
New episodes of Practical AI premiere every Monday.
Find the show at changelog.com/practicalai or wherever you listen to your podcasts.